All right. So guys, I will warn you guys, this is a 7-step proof, so this will be a long proof. We're gonna do these 2 proofs and then we'll be done for today. And you guys will have the rest of that time to work on some homework. If you notice, homework's not exceptionally long, but at the same time, I think there's only a couple proofs in homework anyway. Just so you don't look at that and say, oh my gosh, there's gonna be 10 proofs in our homework. It's not that long. So we'll continue on with our notes here. So again, they want us to do a 2-column proof, so we'll set that up. So statements, reasons. Again, I'm going to switch it though, so we can make it a little bit easier on ourselves. I'm going to call this, which way did I do it? I'm going to call the big one angle 1 and the little one angle 2, rather than having to call it angle ABC and CBD, and it sounds like I'm, selling something. So we're going to change that to 1 + 2 = 90, and that angle 1 is 3x - 5, and angle 2 is this fraction. That's okay. And I'm okay with you guys doing that in a proof if you want, if the homework requires that or something, just for ease for yourself. It just depends if you're trying to compare your answers to mine or something, we didn't pick the same thing. So again, we have to start with what we know. So they tell me 1 and 2 together add to 90. Oh, sorry, that should be step 1. And again, this is all given. So I'm going to list everything they gave me kind of in just a list here. So now notice in the proof, they say if, so that's all my given stuff, and then the then is what I'm trying to prove. So they, again, tell me the answer here, but that's not given to me, that's then. So I have to wait on that part. But I can't use the x = 27. All right, we're okay with the 1s and 2s instead of the angles. So the 2 together add to 90, and they tell me what those other 2 values are. So what are we going to do next? Our next step, you guys. Trying to figure out what x is, so what do we need to do? Yeah.
3x - 5 plus x + 1 divided by 2 = 90.
Yeah, so we're putting these in to make them equal 90 as well. So we're going to say that 3x - 5 plus x + 1 over 2 is going to add up to 90. And this one's just kind of a pain because it's kind of a complicated formula here. And remember, when we replace something in math, you're not just putting it in or replacing it, we call that substitution. So now the fact that we had the drawing all together or that we had angle measures even to begin with really doesn't even matter to us. Now we're just going to work with the math behind it. All right, that dividing by 2 might be driving some of you guys crazy. I wouldn't stress about it too much yet. What do you guys want to move first? It looks easy to move. Probably say that 5, huh? Add 5 to each side. Step 3 will be 3x, this is gone, plus x + 2 over 2 = 95. Or that's just the x + 1, sorry, some of you guys are whispering about. Stop me if I'm ever doing goofy stuff like that. Sorry. All of a sudden it sounded weird as saying it. All right. At this point, I think I am gonna try and get rid of the divide by 2. But the issue is when I want to get rid of that divide by 2, I have to multiply everything by 2. So that means also the 3x, that fraction, and also the 95. Oh, so this needs to be addition that I got here. So what I'm going to do is I'm going to multiply everything by 2 to get rid of that divide by 2. But when I do that, I have to do this, this, and that. So the 3x has to get multiplied by 2 as well. So try to get rid of this divide by 2 here. I have to multiply this becomes 6x. This is just x plus 1. And then this is 95 times 2, which is 190, I think, right? And so we did multiplication there. And now, what do you guys want to do? We're going to do next. There's probably 2 things we can do. I'm going to move the 1 or combine like terms. What do you think? Combine like terms. Remember, combining like terms is called what in a proof? Simplify, yeah. So now let's move that 1 over. And then finally, we can divide by 7, and we really hope at this point that x equals 27. That's probably the only thing bad about proofs is we make a bad step way back up there somewhere. You're probably going to be in kind of some trouble with erasing. But we divide now, and we end up with 27, right? So pretty long proof, but nothing like crazy. I mean, the geometry piece of it is very small. I mean, we didn't have to do a lot there to figure out how to get from the geometry proof into an algebra proof. All right, we'll do one more example, and then you guys will have the rest of the time to work. This last one's not too bad, or it's not too long. It's a little bit tougher, though, I think. So in this case, they give us that AC equals AB plus AB. That's kind of a weird statement there. So take a minute to look at that. It's probably not as obvious, like it's not, they're not telling us the obvious. So AC equals AB plus AB. So even if I have no idea where to go with this, I'll start with the given. So even if you had no idea how to do any proof in your homework, you should always be able to write the given statement down. That first step, and you get points for that on a test, that's worth points for writing the given statement down. Sounds silly, but you've told me something you know. I'm trying to prove that AB equals BC. And currently, I don't know that, because they don't tell us anything about what point B is. They don't tell us it's a midpoint or anything like that. We don't know that for sure. So I would suggest trying to use one of our new rules that we learned today. So like on the front side of the paper. What rule do you think we could use in this case? We learned 3 new rules today. And hopefully one of them is completely out of the running because it's not an angle. What do you think? Can you tell me anything about this statement? It's kind of, Michael had told us something about the statement on the front side, or about this segment. What do you guys know about this segment? Do you know B is a midpoint? We don't yet. So what else can we say about this segment? 2 smaller ones give us the bigger one. So we're gonna say AB plus BC equals AC. Do you guys agree with that? The two smaller pieces add up to the bigger one. And this is a weird step, we're just not used to it. We just haven't really used it yet in a proof. We're stating kind of obvious points here, and this is gonna end up being helpful here. Is okay with that? So I said the smaller one, or basically these two together add up to the big one. All right, any thoughts? And I'm totally not surprised if you don't know where to go from here, because this is kind of a weird step. Anyone see anything about, like, if you just saw this information, anyone make any conclusions? They both equal the same thing. Do you guys see that? They both equal AC. So what does that mean we can say about those two parts? What's that? We don't know that yet. We know these are the same length, right? AC is equal to itself, right? So if I know this equals AC, yes, I can say that this AB plus BC equals AC, but that actually equals AB plus AB. You guys okay with that? Do you see what we did there? They both equal AC. If I said they were both, going 50 miles, it doesn't matter how we got there, they're equal to each other. That's 50 units long or whatever it happens to be. What does it mean when I replace something in math? What reason do we use? Substitution, you could use transitive in this case, they both equal AC. Either one is fine. Substitution or transitive. And we're almost there, you guys. We're about 2 steps away from having it. We're trying to prove that AB equals BC. That's what we're trying to get to. If you look here, I have AB on this side. I have 2 ABs. And I have BC over here. But what do you notice? Yeah.
You can subtract 2 ABs.
Yeah, this is kind of weird, but if I had, let's say I had this written. If I had, sorry. If I had x plus 2 equals y plus x, what would you guys do? You'd subtract off an x, right? There's an x on each side. I can cancel those out. It's the same thing we can do here. Whatever we can do in algebra, we can do with segments. So we can take off an AB from each side. That's just subtraction. There's an AB on each side. AB equals itself. I can subtract that from each side. I can cancel that out. So I'm left with BC equals AB. We're super close to being done, and if you would have done a little bit better planning than I did, you would have been able to skip this last step. It's not quite what we want, but it's almost there. We can just flip it. And that's going to be symmetric, right? Great. Questions? All right, homework is listed there for you guys. Again, we're shooting for like a Thursday test. So make sure you guys are stopping in if you guys have questions. Sending me quick emails if you're having issues.